Hello, I'm Robert, fact checker and science blogger, and helping people who are scared of many things. And this is, I get asked by people who are scared that sometime in the future the moon might hit the Earth. And it's a natural enough thought if you haven't got a strong background in astronomy, because it seems quite close. If you look up at it up in the sky, it almost, as a child, you think almost you could reach out and touch it. So could it hit the Earth? And the answer is no. So I'll explain how we know this and what's going to happen in the future. Certainly not for billions and billions and billions of years. So we know, first of all, we know from theory that it should be moving outwards, but we can actually measure it. And when the Apollo astronauts went to the moon, one of the things they put up there are these laser retroreflectors. They are like the cat's eyes that you have on roads, which reflect the light from your own headlights directly back to your eyes. And that's why they're so bright, because they take your headlights light and reflect it directly backwards. And so it's a kind of arrangement of prism shapes which are so designed that any light that goes in comes back out the way it went in. And so it's like a mirror, but from any direction, rather than just having to be directly opposite. And so they put these retroreflectors on the moon, and this means we can fire a laser beam at the moon in a particular frequency, and then a couple of seconds back after that, we can detect a laser beam shining back from the moon to us, and that's the reflection of our laser beam off the retroreflector that was left there by Apollo. And by measuring the exact time it took from when we fired the laser beam in the moon and when the laser beam seemed to fire back from the moon to us, just the reflection, then that tells us exactly how far away the moon is, and you can measure it to centimetres. And so, fractions of a centimetre. And so from that we know that the moon is spiralling out very slowly at about the same speed as fingernails grow, about 3.8 centimetres a year. So that's the Apollo 11, I can't bring that up, the Apollo 11 lunar lander retroreflectors. So why is this happening? It's because the Earth's tidal bulge spins ahead of the moon. So you know with the tides that they go up and down about twice a day, most places. And that is, do I have a picture of the tidal bulge here? No, I don't. Okay. So in most places on the world, I can talk about in a separate video, most places on the world there are two tides, one on the side towards the moon and one on the side away from the moon. And it's I explain a little bit about how it works. I explain that in a separate video because it gets a bit complicated. But what happens is that the tidal bulge is raised by the moon. It's the moon's gravity that raises the tides. It's the main thing that raises the tides. The sun also has a tide as well. So the two of them combined together is why you sometimes get very high tides when they're both in the same direction at full moon or at new moon. But the moon always gives a tide, and as the Earth is spinning around, then the Earth spins around faster than the moon does, and the moon raises these tides in the Earth, or in the Earth's seas, and because the Earth is spinning faster than the moon, then the Earth carries these tides ahead of where they would be. So the moon raises the tide, and the Earth carries it a little bit ahead. And the moon then is pulling at the bulges, which are always a little bit ahead. And so the moon is pulling the bulges backwards, because it's pulling from the sideways, because the Earth, as it spins the bulges around into forward. And so that pull of the moon back on the bulge that it itself created slows the Earth down. And originally, when the moon formed billions of years ago, then the Earth had a very much shorter day of just a few hours. And it's now, as we know, 24 hours, and the Earth's day is getting longer and longer and longer. And then it's very complicated, funny, very strange thing. You would think that this would pull the Earth inwards, but it pulls it outwards, it moves it outwards. As the moon is slowed down because of the bulge keep continually going ahead. And that slowing down actually pushes the moon out into a more distant orbit. because if you think about it, so it slows down the Earth, it also slows down the Moon, which is getting longer and longer months as well. And if you think about it, the International Space Station goes around the world in an hour and a half, and the Moon goes around in about 28 days, and it's much further away. And the more the Moon slows down, the further away it goes. And so this pulling of the tidal bulge is what makes the Moon go out further and further, because it slows down both the Earth's orbit, Earth's rotation, and the Moon's rotation, and makes it go out further and further and further. And so, and that's going to keep on going, and the Earth's day will get longer and longer and longer, and the Moon's month will get longer and longer and longer. But if you go forward about 50 billion years, then eventually they synchronize. Obviously it's a very, very long day for the Earth. So originally the Earth's day was just 6 hours long, and the Moon had a month of about 15 hours. Now it's 24 hours long, and the Moon has a month of 28 days. But if you go very, very far into the future, then eventually the Earth's, this is if you go very far in the future, if we forget about the red giant phase, which is billion years of years in the future, then at around 50 billion years from now, then there will be a month of 42 days, and the Earth will have a day of 42 days. So that's what eventually happens. If you forget about the Sun, you just look at the Earth and the Moon and nothing else, then because the Earth, this tidal effect would work even if there wasn't a Sun. The Earth would be spinning and the Moon would be slowing it down, and then the Moon's orbit would keep on spiraling outwards and outwards until eventually you'd end up with an Earth having a day of 42 days and the Moon having a day of 42 days. And at that point, then it would just be like that forever, going round and round and round very, very slowly every 42 days, with always the same side of the Earth looking towards the Moon. So there would be one side of the Earth facing towards the Moon, and it would always be facing towards the Moon. There would be another side of the Earth where you couldn't see the Moon. And the Moon would always be facing towards Earth as it is at the moment. We always have the same side of the Earth, Moon facing the Earth. Now, there is a planet that's already happened to, and that's Pluto's and his moon Charon. They have already gone through that process, and both the moon Charon and both Pluto and its moon are now locked to each other, just like Earth would be 42 days in the future, with a 42-day day and month, about 50 billion years in the future. So now, if we suppose that the Earth and Moon did, I'm forgetting about the red giant phase for now, I'll explain that in a bit. So if we forget about the red giant phase, or if we could move the Earth far enough away from the Sun, which might be a possibility for future civilizations, while keeping the same orbit for the Moon, then the Moon and the Earth would continue rotating, eventually slow down to 42 days, and that would be very far in the future, where at that point the Sun would have gone all the way through the red giant phase, the planetary nebula. It would end up as a very small white dwarf. Then gradually, through the tidal effects of this Sun, then the Earth-Moon system starts to lose its angular momentum, because the Sun is continually tugging at this, and it slows it down. It's very similar to the way the Earth slowed down because of the Moon's gravity. Then the Earth-Moon system, with both of them being locked, they would slow down because of the Sun's gravity over an immensely long period of time. And so now, very, very, very long time scales, then if you go beyond 50 billion years, it's reached 42 days each. So it keeps slowing down until you get 42 days each, both for the Earth's day is 42 days and the month is 42 days. Day and month are both 42 days. And then it starts speeding up, and then after another few tens of billions of years, it'd be 40 days, 39 days, 38 days, but with them tightly locked. So now they start speeding up, and up and up and up, and over immense periods of time. I couldn't find a time scale for it, what the time scale was. But eventually, of those really immense time scales, then the Moon would start spiraling in and in and in, until eventually, over immense time scales, it wouldn't hit the Earth, It would come within the Earth's. Oh no, I know it would. It would. Sorry, it would be stable because of its tidally locked. So it comes closer and closer and closer, and then eventually, eventually, I'm not sure if it would. I say there it would eventually get get within the Roche limit, but it's tidally locked with the Earth. So I don't think. I'm not sure if that's quite right. I'll have to check that up. I think eventually it would just be tidally locked with the Earth and get closer and closer and closer until you eventually. It's almost like a dumbbell-shaped planet. I know that a dumbbell-shaped planet is stable. So I think eventually it might just end up with the Earth and the Moon touching each other and then merging together and becoming a big sphere of just the Earth and Moon as one planet. I'm not sure about that. That Roche limit doesn't make sense because you haven't got any tidal effects anymore because it's just one single bulge. And so then eventually, so then you end up of those huge time scales. However it is that what happens when they two merge, you then have a very rapidly spinning Earth. You'll be back very close to that original 5 hours or whatever spin. But then on very long time scales, then the Sun will act on that through tidal drag, and eventually the tidal locks, it would eventually become a tidally locked Earth always facing the Sun. I'm not sure about that bit about the ring system. I probably got it from someone, but I'm not sure if they got it right. So then that is if you forget about the red giant phase. But if you look at the red giant phase, then I've talked about this before in a separate video. That as the sun at the moment is very stable for billions of years, just getting very slightly warm and warmer, and at 300 million years from now we get the possibility of a moist greenhouse effect, where the oceans start to, there's so much water vapor from the oceans and you get a kind of feedback loop. It can't happen now, but about 300 million years from now, it doesn't go all the way to a Venus effect, it just goes to about 59 degrees centigrade. And that would happen about 300 million years in the future. And that is too warm for humans, except maybe at the top of mountains or something. So in that far future, but then it could be differently evolved creatures that have evolved over that vast time scale. Enough time, almost enough time to evolve to humans from microscopic things in puddles. So you're talking about a very vast time scale. Then we get to the point where Earth could get too hot for humans. And then on that time scale, but we're talking about much longer than that before we get to the red giant. Before we could get, so first of all, at that point, if there are humans still there, but we've probably evolved into something else, then we can block out the sun with the various ways we could do that. Just something in the L1 position, balanced in the gravitational balance between the Earth and the sun, would do it. Or we can move Earth out. And there are ways we could do that already. They're very risky for civilization at our early stage, but we could set a big comet or asteroid in orbit, going around Jupiter and going around the Earth, back and forth, continually guided by us, and it carefully does a close flyby of Earth without hitting, and a close flyby of the Moon, of Jupiter, and back and forth. And you can arrange to do that in such a way that it actually pulls Earth out and out. It's transferring some of Jupiter's orbital momentum, angular momentum, to the Earth, so the Earth goes further out. And so then, Jupiter would hardly move at all because it's so much bigger than the Earth. So that is one way. There's another way that involves using a big tower at the far side of the Moon and using and generating electrical currents through that. Maybe using huge solar arrays around the Moon to generate the current. And over billions of years, then there's a way of using that to make the Earth gradually spiral outwards. And I'm sure there could be various other ways with our technology that we could do that. So that's another possibility. You're talking about billions, about hundreds of millions of years if you want to do that to avoid the moist greenhouse effect. You just push the Earth out a little bit, you wouldn't have to push it very far, just a few percent, to avoid the moist greenhouse. And then once we've set that up in order to avoid the moist greenhouse, we can then just keep on going and keep always at a comfortable limit all the way through to red giant. And then once you're well outside the atmosphere of the red giant, then you can use mirrors, you can use shades in order to, as the sunlight fluctuates, to make sure there's always enough sunlight gets to the Earth and never too much. So it would be possible to manage the Earth like that, to make sure that it's always habitable. And or we could all be living in habitats throughout the solar system, probably both. And in the habitats with spinning for artificial gravity, and then you use huge thin film mirrors to gather exactly the amount of sunlight you want. You can put up whatever radiation shielding you like between you and the sun for any solar storms. And so that's another way. So there's no problem with future civilizations. I think we're ineradicable basically. I think we've already reached the level of technology where there's no way humans can go extinct. That's the way that I see things. So in one way or another, there will be humans or some other creature that's evolved from us in this far distant future. So what happens if the Earth orbits if we suppose they do that with the Earth, then all that I explained about the Moon and 50 billion years before we even think about it coming in again. So there is something else that happens before that 50 billion years. As the Moon spirals out at the moment, the Moon is stabilizing Earth's axis, and it helps keep it vertical relative to the Sun. Whereas Mars's axis is much more variable because it hasn't got a big heavy moon, and so it's constantly tilting. Sometimes it can be tilt all the way to the point to which it has ice sheets around its equator, and it's the poles that are the warmer parts. So that could conceivably happen with Earth once the moon goes beyond a certain point, that it's so far away it's no longer stabilizing Earth's spin axis so much. So there would be times varying over millions of years. There would be times when the Earth had equatorial ice sheets, like happens on Mars at times. So that would be a possibility, and if we don't like that, well, one way to do that would be to stop the moon from spiraling out, and there would be many ways we could do that. If it's possible to move the Earth away from the Sun, it's certainly possible to move the moon closer to the Earth, if that's what we want. And again, you do it by, or a simple way would be taking some big heavy object, some big heavy asteroid or something, and doing constant flybys of the moon and something else, and use that to make the moon spiral out. So I haven't seen anybody work that out, but it's certainly, there would be ways of doing that. So the I don't know. I'm not going to speculate about how to do that. I haven't thought through how you would do that. You could do it with the Moon and Jupiter for sure, but maybe you can do it somehow with the Moon, Earth, Sun system as well. Anyway, because that's got very complicated gravitational fields, and there may well be ways you can exploit that by sending an asteroid around in those fields and use it to change the position of the Moon. Anyway, so but if suppose that there's no civilization is involved in doing anything to the Earth, or suppose that whatever civilization it is just decides they've left the Earth, they're in space, they're all in space habitats, and they don't mind what happens to the Earth anymore, and the Earth gradually gets hotter, and people just move into space as it gets hotter. Then, in that situation, if they don't bother to do any of this, then eventually the Earth will orbit inside the extended atmosphere of the red giant's sun, as the sun will eventually get so big in that future that we would actually be in the outer atmosphere of the sun. You're talking about billions and billions of years in the future, about 6 billion years in the future. Then we would be in this atmosphere of the sun. And so in that far future, then the moon would be under the friction of flying through the extended sun's atmosphere. The moon would start spiraling in towards the Earth. And then it would hit the Roche limit in that point. And at that point, because it's spiraling faster, it's not tidally locked. Then it would disintegrate it, and Earth would have a ring system like Saturn. But that wouldn't last long. The dust particles would soon get stripped by the solar wind. And so this is a 2008 paper that calculates that to avoid that, the Earth would need to be 15% further away from the Sun than it is. So that also gives an idea of how far we'd have to move the Sun to avoid that fate. So we'd have to move it at least 15% further away from the Sun, which would be feasible over those timescales of billions of years. So, okay, I expect that's where I haven't actually seen that. So this bit here, I think I've made a mistake here. I think that's probably just me. I made a mistake here that the bit about the Roche limit as it comes in. So this Roche limit thing, I'll fix that. I think it's just going to take, I think if you take that very immense time scales, I just haven't seen someone has worked it out all that way to the very, very far future. So if we don't do that, and then over 50 billion years it's 42 days, and if we don't stop the moon from spiraling out further, then it's 50 billion years to the 42 days, and then it starts spiraling inwards. That much I've seen, but I don't think I found an article explaining all the way down to what happens when eventually it reaches the Earth are tightly locked. But I think it would be like if they get closer and closer, like Pluto and Charon, and they'd be tightly facing each other. There's no reason for them to disintegrate. They just get more and more elongated, and eventually as they get closer, they'd be spinning very, very fast and touching each other. I think that's what would happen, and then they gradually merge together as after that. So now, what happens as a result of human activities? Oh yes, that's another idea. There's this idea of setting up a continuous conveyor belt from the moon to the Earth and back. It's like, that's reducing the moon. That would reduce the mass of the moon. I think that's the main thing that could change it. And did I work out what would happen? And then you'd also have materials delivered to the Earth via aerobraking. Yes. So then that could either speed the Earth up or slow it down, depending which way these you get it. So we could actually slow the Earth's orbit, Earth's day down if we wanted to, by returning materials from the moon in such a direction as to be aerobraked in a counter-orbit, counter-rotation way. So we could use returning materials from the moon to the Earth to slow Earth's spin down. And there is a way of returning materials from the moon. Basically, the moon is higher in Earth's gravitational well than the Earth is. Just like if you let something go and it'll fall. So if you could drop something off the moon towards the Earth, but you can't just do that. Sadly, because Earth is in orbit, then you can't just, if you let something go, it'll just keep orbiting, even if you threw something off the moon. But there's a very clever way of using two orbital, a spinning tether that orbits the moon. So it's something that spins, it's a tether that sometimes touches the surface of the moon, and then spins right up, way up into way away from the moon, then back to the moon, and there's two ends to it. And those two are constantly going around like that, and they come close, and then when they're near the moon, you can make it so they're stationary relative to the moon for a long enough tether. And so you can put things onto it when it's near the moon, just for you've got a few minutes to put stuff onto it, and then it goes up again, and then this tether then can throw things off to another tether in Earth orbit. And it turns out they can do all this without any fuel. It is actually powered by the materials that it transfers from the moon to the Earth, because the moon is higher in Earth's gravitational well. So there's a way of using materials from the moon to power a couple of tethers which don't have any fuel to them. They're just powered by the momentum transfer of adding things onto the tether at the moon end, and then taking them off the tether at the Earth end. And at the Earth they get into the atmosphere through aerobraking. And so that system can then transfer angular momentum from the moon to the Earth. But you can, and that can transfer material from the moon to the Earth. And then depending how you do it, you could do different things to the Earth's spin. So instead of doing a nice gentle tether at the other end, you could send it so it glances past Earth and does aerobraking if you did lots and lots of small bits, broke it up into small bits so it's not dangerous, then that would be a way of air braking the other way around, and that would affect Earth's spin in whichever way you want to go. So all sorts of things we could do, if whether you'd want to do that. But so anyway, but our activities on the Earth itself also, of course, increase or decrease its rotation rate. Just walking in the direction of the rising sun will slightly increase Earth's rotation, and if you walk in the other direction, Earth's rotation will slightly slow down, but by an immeasurably tiny amount. But things like trade winds blowing against mountains, they have minute effects on its rotation rate and the length of day. And I already talked about that in an earlier video. So, and so also does the slow rebound of the ground rising after the ice melted after the last ice age. And windy weather, geological shifts such as earthquakes and global warming, should shorten our day by 0.12 milliseconds over the next 2 centuries, because the way heating the ocean changed the way its mass is distributed. And jet engines but then we have the day getting longer because of these tidal effects, so they counteract each other. And and jet engines from aircraft, they speed up or slow it down, and driving along the road and so on. But all of these are very, very minute effects. And but if you wanted to you could do things to change the Earth's spin. You could, for instance, set up a giant conveyor belt all the way around the Earth, and if with future technology filled with the vacuum, you just send things constantly going around, material constantly going around. And now wait a minute, no, that wouldn't work, because as soon as right, yes, so something explained. If you walk along the road, then while you're walking towards the rising sun, then the Earth is speeding up. But when you stop walking, the Earth would all that extra spin you added is removed again, because because you're adding to momentum by walking. Then you're stopping. You no longer have any extra added angular momentum. So, but if you were to walk all the way around the Earth and keep walking around the Earth, then that would add to the Earth's angular momentum. No, even that wouldn't work. And even with a jet, if you fly and then stop, you're still not adding to the Earth's angular momentum. So, again, what did I actually say there? So, but yes, there you are. I do actually said that. I said that. But when you stop, its rotation returns to what it was before you started walking. And it's the same with the jets. So if you get into a plane and you fly from one place to another, then while you're flying, you have slightly increased or decreased the Earth's spin rate during your flight. But as soon as you stop and get off, then it returns to what it was before. This is a tiny, tiny, totally immeasurable amount, fraction of a fraction of a fraction of a microsecond. It would be very impossible to measure. But that's what happens when you move around on Earth's surface. So all our activities on Earth's surface, most of them are not going to do anything to the rotation rate of the Earth in the end. But there are some things that do increase or decrease it, and that includes things like trade wind, because that is using the solar energy to put up a dynamic in the winds, with blowing the winds against the mountains, and the actual it's the sun influencing the Earth in various ways and expanding the sea with the warmth of global warming. That is like putting your like a skater. Now what have I got there again? Global warming should shorten our day by 0.12 seconds. I've got a Scientific American thing here about that. Sorry, I probably should have. It looks like I've got to do a little bit more work on this. Let's see, fact or fiction. So global warming. Here we are, that the Moon and Sun's gravity had 1.7 milliseconds length of the day each millisecond. And that's what I just explained. And then I've got to be signed in I've got to be subscribed to read this properly. But the global warming also has a very minute effect in the other direction. Ah, anyway, so I just wanted to talk about the last bit about Earth, Mercury hitting the Earth or the Moon. And so this again is over a very immense timescale in the future. And it's another way that the Moon's orbit could be affected. This is a very minute chance. If you look at billions of years in the future, the Mercury can fall into resonance. Mercury is our lightest planet, which is closest to the Sun, and Jupiter is our heaviest planet. And the gravity of Jupiter interacting with Mercury, which is so close to the Moon, and pulling at that and tugging at it, if it is a certain resonance that can be set up, and it's not in that resonance at present, but it could get into that resonance about 3.5 billion years in the future. And then if Mercury gets into that resonance, then they found that out of 2,501 cases, one of them had led to complete stabilization of the inner solar system, and of those, looking at 201, you got you got 5 cases where Mercury hits the Earth, and there would be a tiny fraction of a probability of it hitting the Moon as well. So this is very far in the future. This is not expected to happen. There's out of 2,501 cases, 2,500 cases, there was nothing happened. So this is not expected to happen. And in that remote possibility, in that very far future again, as long as we have a civilization like ours, and we notice that Mercury's orbit is getting more and more elongated, and we discover that this resonance has been set up, then we could do things to push back the Mercury back into its original orbit again. And there we could set up a big asteroid in an orbit going around Mercury and Venus, which would no hazard to Earth, and that could be used to transfer Venus's momentum to Mercury at strategic moments to stop Mercury from getting more and more elliptical. So there would be many ways that we could do something about that as well. And but who knows what, there'd be many other ways. We could probably put things on the Mercury that would push it around as well. As long as we've got a civilization at least as advanced as we have now, or whoever exists there, then they would be able to do something to stop Mercury from hitting Earth or the Moon in that very remote chance, but it's not expected to happen. So, or maybe they decide they like to have Mercury hitting the Moon. I think that's a bit unlikely though. But if Mercury did hit the Moon, obviously that changes everything, and it would basically take the Moon away from our solar system, the Earth-Moon system. And if Mercury hits the Moon, well, some of the debris from the Mercury-Moon collision could form a new Moon, which could eventually maybe hit the Earth in some situations. Anyway, sorry, this is an article, this announcement I wrote some time ago, and obviously a couple of things I need to change. I need to explain about I take away that bit about the Roche limit, and that they would be synchronized. I need to explain that the Mercury hitting the Earth or Moon, I need to explain that to be some of the debris from the Mercury-Moon collision in that so that is something that could happen if there's no civilization around to do anything to stop it, and in a very, very remote chance, then about 3.5 billion years from now, then there is not expected to happen, but it could be. It in some alternative reality, it's not impossible that Mercury could hit the Moon in that very, very distant future. But none of this can happen now. So anyway, I hope that might interest you, all the ins and outs of all the complexities of the Earth-Moon system. And it's quite fun if you're interested in astronomy, looking at these various possibilities. But there's nothing that has any relevance to us as we are today. This is talking about immensely far distant future, and whatever we are in the future, then as long as there's some civilization, we can basically shape this to make sure that the Earth stays safe, if that's what we want to do. By the way, you may notice my volume level here. I've discovered that my voice often gets rather quiet, so I'm keeping an eye on that. I've added a volume meter which I will use to make sure that my voice doesn't go quiet as I keep talking in these videos, and hopefully eventually I will get used to that. So anyway, hopefully this helps some of you who've got scared of the moon hitting the Earth. There's no chance of that. I could have kept it very short and simple, but I thought I'd go into some of these other details for those of you who are interested in the astronomy behind it. And so I'll upload this. If you are good at fact-checking, then I'll just remind that we've got our Doomsday Debunk group on Facebook, and then where we help people who are scared of many things like this and many other things. And then if you are good at fact-checking, or if you are scared of these things, though, do read the rules at the head of the group before you post or comment, to have a glance at them at least, because they help the group to work, function properly. And so we can help you with these fears. Sometimes some people find a bit much, because we get so many of these things being posted to the group, like, never even thought about the moon hitting the Earth, and then you get someone saying, could the moon hit the Earth? And they start getting scared until someone comes up with a debunk like this. So, if you can do an awful lot to help these people, if most people there, the people there, they get very much helped and reassured when they get scared of something like that. And they go to our group, and there's nowhere. If you go and search on Google, you'll find all sorts of extraordinary things. And so, and people will say almost anything that you're scared of, someone on Google will tell you that this is going to happen. So we help by fact-checking. And so if someone on Google tells you that the moon will hit the Earth, no, that's not possible. It can't happen. The moon can't hit the Earth. And this, I've explained some of the background of how we know. But the very simple bit is this very simple thing, that we can actually measure that it is moving away very slowly at the speed of your fingernails. So there's no way it can hit Earth, because it's moving away. And it's moving immensely, very, very slowly. The 3.8 centimeters is nothing compared with the distance from the Earth to the moon. So it's not going to go away a significant distance, even over millions of years. It's not going to be any significant difference between what it is now. Only over billions of years and billions of years, then other things can happen. And whatever technology we have can do something about that, if we decide this is of any concern. And that basically is that. So, okay, I'll upload this, and hopefully this will help some of you.